morning, students. In earlier classes we have discussed about the Laplace transformations, inverse Laplace transformations, then the application of the Laplace transformations. Today we are going to discuss another important transformation which is known as the Fourier integral transformation. Another integral transformation which is known as the Fourier transformation. So today we will discuss about Fourier transformations or Fourier transform. There are three types of the Fourier transformations or Fourier transforms. One is known as the simple Fourier transformation, or we say Fourier complex transformation. The another one is Fourier sine transformation, and the third one is the Fourier cosine transformation. So first we will discuss about the definitions of these transformations. So first we take Fourier transform or Fourier complex transform, which is also known as Fourier transform. So, what is the definition of the Fourier transformations? If a function fx defined on x which lies between minus infinite to infinite. If a function is such that if it is defined between minus infinite and infinite, minus infinite and plus infinite, then the Fourier transform or Fourier complex transform, Fourier transform or Fourier complex transform of fx is defined and denoted by Fourier transformation of the function fx with respect to parameter p. The Fourier transformation of the function fx with respect to the parameter p, and it is defined as 1 upon root 2 pi integral minus infinite to plus infinite e raised to iota px fx dx. The Fourier transformation or the Fourier complex transformation of a function fx which is defined in the interval minus infinite to infinite is denoted by Fourier f of fx with respect to the parameter p, and it is given by the integral 1 upon root 2 pi integral minus infinite to infinite e raised to iota px fx dx. Another transformation is known as Fourier cosine transform. The Fourier cosine transform, if a function fx defined on x lies between 0 and infinite, then the Fourier cosine transform, then the Fourier cosine transform is defined and denoted by the Fourier cosine transform is denoted by F.C. The F.C. which function? F.C. of f(x) with respect to parameter p. F.C. of f(x) with respect to parameter p, and it is equals to root 2 upon pi integral 0 to infinite f(x) cos px dx. The Fourier cosine transformation of the function f(x) is denoted by Fc fxp, and it is defined by the integral root of 2 upon pi integral 0 to infinite f(x) cos px dx. The another Fourier transformation is the Fourier sine transformation. The Fourier sine transform Fourier sine transform of a function f(x) defined on x lies between 0 to infinite, defined on 0 to infinite is defined and denoted by the Fourier sine transformation is fs of fx with respect to p. S denoted for the sine, so fs of fx p is equals to, this is root of 2 upon pi integral 0 to infinite fx sine px dx. It is known as the Fourier sine transformation. It is also denoted Fourier sine transformation. It is also denoted by FSP. Similarly, the Fourier cosine transformation is also denoted by FCP. And the Fourier complex transformation is also denoted by F of P. So, we can define here the three important transformation known as the Fourier complex transformation or simply Fourier transformation, the Fourier cosine transformation and the Fourier sine transformations. Similarly, the inverse transformation can also be defined. The Fourier inverse transformation. Fourier inverse transformation. If Fp is the Fourier transform of fx, then fx is inverse Fourier transform of Fp. If Fe is the Fourier transformation of fx, then fx is the inverse Fourier transformation of Fp, and fx is given by the Fourier inverse f of p with respect to x, and it is given by 1 upon root 2 pi integral 0 in minus infinite to infinite e raised to minus iota px fp dx. the inverse Fourier transformation or the inverse Fourier complex transformation of fp is given by fx, and it is equals to 1 upon root 2 pi integral minus infinite to infinite e raised to minus iota px fp dp. Similarly, the Fourier inverse Fourier sine transformation, inverse Fourier sine transform. If FSP is Fourier sine transform of fx, then fx is equals to inverse Fourier sine transformation. Fx is equals to inverse Fourier sine transformation of FSP with respect to x. Fx is equals to the inverse Fourier sine transformation of FSP is known as the inverse Fourier transformation, and it is given by under root of 2 upon pi integral 0 to infinite f of p fsp sine px dp. Similarly, the inverse Fourier cosine transform the inverse Fourier cosine transform, if FCP is the Fourier cosine transform of fx, then fx is inverse Fourier cosine transform of FCP, and it is given by fx is equals to f inverse of FCP with respect to x, and it is given by root of 2 upon pi integral 0 to infinite FCP cos px dp. So if we have a function, then we can find the Fourier transformation or the complex Fourier transformations, the Fourier cosine transformation and the Fourier sine transformation, and subsequently we can also find the Fourier inverse Fourier transformation or inverse Fourier complex transformation and inverse Fourier cosine transformation, and finally the inverse Fourier sine transformations. So these are the basic concept or basic results or basic formulas for the Fourier transformation of three types. Thank you very much.